Hello guys, in this video, we are going to build a machine learning system that can predict gold price based on several other stock prices. Now let's understand the workflow. First, we need to get the gold price data. We have gold price data for several days in a period of 10 years. We will be using this data to train our machine learning algorithm. When we give value, it can predict the gold prices for the specific value. Once we have the gold price data, we need to do some data pre-processing. So we cannot fit this raw data to our machine learning algorithm. So we need to process this data properly. And once we process the data, the next step is to analyze the data to know which features are important, which features are correlated with each other, and apply some data visualization technique. We will be seeing in data analysis part the whatever the correlation and the data visualization techniques we will do. So after that, we will apply train test split. We will split the data into training and test data. We will be using training data to train our machine learning model, and we need to evaluate our model with test data. In this case, we are going to use random forest regression model. This is a regression problem, so we will use random forest regression model. Once we fit training data to the random forest regressor, it will give new prediction. Once this model is trained, we will evaluate it based on the test data. So now let's get into the coding part. So let's start. So we will be doing our coding part in Google Colab. So first you have to upload the dataset. The dataset link I will provide in the description below. So this is our gold price dataset. So let's start with importing the libraries. The libraries are nothing that which we will they are these are the libraries which we will use in while making our machine learning model. So let's import that. Put numpy as np. Import matplotlib.pyplot as plt. cpon as sns from train test split from sklearn dot ensemble import. We will use a random forest regressor. So finally, we will import our evaluation matrix for evaluation purposes. So we will run this. So numpy as np is used to make numpy array. Pandas as pd is useful for making data frame or you can say a structured table. And matplotlib and seaborn is used for plots and graph. And random forest regressor is an ensemble model. It comes under ensemble technique. So we have to import from sklearn.ensemble, then the random forest regression. And finally, for evaluation purpose, we will import matrix. So now let's load the CSV data to pandas data frame. So you have to open this folder and click on these three dots and copy the path. And you have to paste it here and run this. So now let's check print the first 5 rows in the data frame. Gold data, and that we will do by using head function. So these are the first 5 column names, that is date, SPX, GLD, USO, SLV, and Euro or USD. So date it's in month, followed by day, followed by year, and here SPX index means it is a capitalization index of top 500 companies which are publicly traded. It is one of the stocks that is available. So, and the GLD is the gold price. This is what we are going to predict. And USO is United States oil price for this data, for these dates. So SLV is the silver price value, and Euro and USD is the currency. So we will print also see the last 5 rows of the data frame. We can do that by using tail function. So let's do that. Gold data dot tail. So here in head it shows the first 5 rows, and with the tail it shows the last 5 rows. So now we will count a number of rows and column, and that we will do by using shape. So you can see there are 2290 rows and 6 columns in this data set. So we will now get some more information about this data set. So let's proceed. So we will use info function. So you can see that date is like object, and rest are all floating numbers. So now again, let's check is there any missing values in our data set or not. So we'll do that by using is null dot sum. So you can see that there are no missing values in our data set. This is quite good. So let's proceed with the statistical measures. We will apply some statistical method with our data sets and see what is there in the data set. And we'll perform the statistical measure by using the functions describe. So this describe function shows the count, mean, standard deviation, minimum, and 25 percentile data, 50 percentile data, 75 percentile data, and the maximum data for each column. So like 25 percentile data, like this value is this is a 25 percentile data. So Now let's proceed with some more data analysis part. So we have to check whether these columns are correlated or not. So basically there are two types of correlation, like positive correlation and negative correlation. So what is positive correlation? Like if one value increases, the other value also increases. So that is a positive correlation. And if one value increases and the other value decreases, then it's called as negative correlation. So let's proceed with that and check whether our any columns are correlated or not. Correlation equal to goal data dot corr. So and how we will check correlation. Very common method is to construct a heat map. So we will construct a heat map to understand the correlation. So plt dot figure fixed size equal to, let's say we will keep it as 8,8, and we'll input fns dot heat map. So correlation comma c bar equal to true, square equal to true, and fmt will keep it as let's say 0.1 f, and not true, and not kws equal to size. We'll give, let's say 8 only. So and c map equal to blues. We will run it. So you can see that this is a c bar, and point fmt means 0.1 decimal value. Annotation, these are the annotation we are giving, and the annotation size is 8, and the color is blue, so it's a c map equal to blue. So now we will see that these are the correlation values of each column with respective columns. So now I will find the correlation value of gold column. So I will print it. Correlation, and that is GLD, and shift enter. So you can see that gold price, if gold price increases, silver price also increase, and if USO value is decreasing, then the SPX value is increasing. So you can see with that this map also. So now we will check the distribution of the gold price. So we'll check by using disk plot. We'll select color as green. We'll run it. So you can see that most of the values lies in the range of 120, less value around 180, and less value at 770 marks. So we have a bump in around 90 and 160, but majority of the values are in 120. Density is nothing but the number of values we have. We can clearly see that more values are in 120 range. So let's proceed with splitting the features and target. So gold data dot, we will drop those columns which are not required for model training purposes. That is our date and our label column. Gold data. We'll run it. So now we will see the value of x and y. So we will print the value of x and y and see. Print x. This is the value of x, and we'll print y. And you can see that this is the gold price values. So now we will do the split our data into training data and test data. X train, X test, Y train, comma, Y test. So we'll use train test split X, Y, our test size. Let's say we will take 0.2 and random state equal to 2. So we'll run it. So basically the test size is 0.2. That means 20% of the data set will be taken for the testing purposes, and the remaining 80% of the data set will be taken for the training purposes. And random state equal to 2, like it will split the data in the same way as I am splitting. So generally it is used to reproduce the code. So now let's do model training with our random forest regressor. Regressor equal to random forest regressor. So here we will give an estimator value. An estimator, let's say we will give 100, and we will run it. So now we will train our model. Regressor dot fit. We'll train our X train and Y train. So our model has been trained. So now we will evaluate our model and we will predict our prediction on the test data. So test data prediction equal to regressor dot predict X test. So it's done. So we will print the test data prediction now. So you can see that these are the values of test data prediction. So we need to compare this predicted value with the actual value. So for that, we will use RSquare. RSquare is it is used for evaluation purposes. So RSquare score is generally between 0 and 1, and RSquare measures the best fit of the data set. Like if it is like 0.85, then 85% of the data is fitting in our data, real data set. So let's calculate the RSquare score. So R score equal to matrix dot R2 underscore score y test comma test data prediction. So we'll print this R squared value, print R squared value so there is some error. Print R square R score. Okay, I have given a wrong name here. R score. We'll run it again. So you can see that almost it is coming out to be 0.98. So like model is performing quite well, like 98% of the data is fitting our data set. So then now we will compare the actual values and the predicted values in a plot. So we will do that. So for that, first we have to convert this test into a list. So otherwise, if we are not converting it into the list format, so otherwise it will give some error while plotting. So it's better to convert that text value, y test value into a list format. So now we are ready to plot our graph. Y test color and color, let's say blue, and label equal to actual value. Again, lt.plot test data prediction. Color, I will give it as green. Label will be the predicted value. So now we will give the title, and the title will be actual price versus the predicted price. So PLT dot title actual price versus predicted price. So now we'll give the X label. In next level, we will give the number of values. So in Y level, we will take the gold price. So we'll write gold price. CLD price. We'll do PLT dot legend and PLT dot show. So legend is like this this actual value and the predicted value it's showing, and this is called the legend. So you can see actual price and the predicted price and values are very close to each other. Actual price is slightly more than the predicted value. That means we have successfully used this random forest regression model to find the gold price based on several other stock prices. So that's it. That's all from my side. Hope you enjoyed the video. Thank you.